All right, number 13, we're doing transformations. First job is to figure out what is the parent function and then come up with the mapping rule that we're going to use to manipulate the graph. So it's the parent function is a quadratic, and the parent ordered pairs for that would be negative 1, 1, 0, 0, and 1, 1. It's one of those memorized facts I said you got to get down. Okay, so the mapping rule. Okay, so in this case, the only thing that's going to change the x's is that plus 1 in the middle, and it does opposite of that, so it's going to subtract 1. The 3 is going to multiply our y values, and then we're going to minus 2 from them. Okay, so just quickly setting up my 3 points. Negative 1 take away 1 is negative 2. 0 minus 1 is negative 1, and 1 minus 1 is 0. Alright, 3 times y minus 2. So 3 minus 2 is 1. 3 times 0 is 0, minus 2 is negative 2. And then same thing we had earlier. 3 times 1 minus 2 gives me 1 again. Okay. So when I come over here and plot it, negative 2, 1, it's right there. Actually, no, it's not. It's negative 2 1's right there. Negative 1, negative 2 is down there, and 0, 1 is right there. So I can see that this particular parabola looks just like that. Okay, and that's all I'm looking for. Just give me the ordered pairs. Give me a rough sketch. That's fine. All right, number 14, our parent graph is the square root graph. So the ordered pairs for it would be 0, 0, 1, 1, and 4, 2. The mapping rule. So what are we doing in this transformation? It looks like the x's are going to be adding 2, and the y's, it's a 1/2 there. Apparently, anyways, on the test it's a little clearer. So it's a half times the y and then add 3. Okay, so where are our points at now? So 0 plus 2 would be 2. Half of 0 is 0 plus 3, so 0, 2, 3 is the first point. 1, 1, let's see. So 1 plus 2 is 3. 1 times, so half plus, so 3.5. And then 4 plus 2, so 4 plus 2 puts me at 6. And half of 2 is 1 plus 3, 4. Okay, so 2, 3 right there. 3, 3.5, so a little bit above it. And then 6, 4 is right there. So our graph looks about like that. And next up is this guy. So our basic shape, it's a cubic. And the parent ordered pairs would be negative 1, negative 1, 0, 0, and 1, 1. The mapping, the x's, looks like we're subtracting 2 from it, and the y's we are subtracting 2 from. Okay, so where are our new points? See, negative 1 minus 2 is negative 3. So negative 3, negative 3, that was nice. 0, so that'd be negative 2, negative 2, and negative 1, negative 1. Okay. So negative 3, negative 3, negative 2, 2, and negative 1, 1. And then just got to remember to put the curve in it like it's supposed to have with the cubic. And that's our general shape. Absolute value, almost done with this, right? Absolute value looks like the V shape. Its critical points would be negative 1, 1, 0, 0, and 1, 1. And as far as our mapping rule goes, looks like we are subtracting 3 from the x's, and we are multiplying the y's by a third, and then subtracting 5. Alright, so negative 1, 1. So negative 1 minus 3 puts me at negative 4. So it'd be 1/3 times 1, so 1/3 minus 5. Let's see, so negative 4 2/3. 0, 0, let's see, so that would be negative 3 and comma negative 5. 1, 1, so negative 2, and then negative 4 2/3 again. Okay. Alright, here we go. So negative 4 and negative 4 2/3 is almost at 5. Negative 3, 5, and negative 4 and negative, okay. So it looks about like that. Alright, number 17, use synthetic division to prove, sounds very severe, that x minus 6 is not a factor of this very long polynomial. Okay, so, well, it says I'm supposed to use synthetic division, so I'm going to do that. 2, negative 11, negative 13, 99, and negative 45. Okay. And x minus 6, so we think of it like we're setting that equal to 0. So I'm plugging in a 6 to see what happens. So we drop the 2. 6 times 2 is 12. Gives me a 1. And then 6 times 1, that gives me 6. Negative 13 plus 6 gives me a negative 7. That would be negative 42. So 99 minus 42, let's see, 7 there, 57. That's nice. Alright, so this next one, maybe you want to type that in a calculator. It's 6 times 57, which is 342. Oh, duh, think about that. 6 times 5 is 300, 7 times 6 is 42. 342 makes sense. And then I want to subtract off the 45, and I end up with 297. Okay, so the question is, what about what I've got on paper currently is evidence that x minus 6 is not, again, not a factor? Where do I look, right? And I'm looking at that 297. So the fact that there's a remainder, well, what number should be there in order for me to say that it is a factor? And that would be 0. So the fact that the remainder is 297 is evidence that it's not a factor. So, in words, since the remainder is 297, x minus 6 is not a factor. Yeah, in some sort of proof, there's the evidence for, and then there's the conclusion of. Now that I've got evidence, what does the evidence tell me to think? And so there's really two parts to this question. There's going to be the algebra part where you do synthetic division, and the second part's going to be, well, what am I supposed to know about this? What am I supposed to think based on what you've come up with? So in order to get full credit for this type of question, then I would want to see that you've justified it and that you bothered to tell me what I'm supposed to think when I see what you did. Number 18 and 19 both are over composition of functions. So f of g of x, the outer function in this case is f. So f is the square root of x plus 3, so something plus 3. And I'm going to write x squared minus 9 on the inside. which is the square root of x squared minus 6. And that's about all we can do, so that's perfectly fine as far as our answer goes. Number 19 is find f of g of negative 2. Well, you know, we just found that lovely formula. Let's use it. See if I can get anything interesting out of that. Okay, so negative 2 squared is 4 minus 6. So 4 minus 6 happens to be negative 2. So that works out to be I square root of 2. So, and that's fine. The question didn't ask us to show something exists. It didn't ask us to solve. It just said evaluate this composition. So at negative 2, then I would get some sort of imaginary number. And that's okay to see. Okay, number 20. I want to just make a list of facts first, and then we'll look at the picture second. So in this case, the x-intercept, I find that by looking at the numerator and setting it equal to 0 and solving. So it is at 4, 0. The y-intercept I get by plugging in a 0. So f of 0 is 0 minus 4 over 0 plus 3. So that's negative 4/3. Okay, so there's our y-intercept. Domain. So what number are we going to kick out? We're going to kick out negative 3. Vertical asymptote we get by looking at the denominator, and that's also our domain restriction, so that's x equals negative 3. And in this case, our HA is y equals, let's see, it's same case, so it's y equals 1. Okay. So I'm going to draw in my asymptotes. I saw this wonderful technique from a student, so I'm going to totally borrow it. So the red line's an asymptote. This red line is an asymptote. And then I'm going to plot any points that I know of. I know 4, 0 right there. Alright, the other point would be 0, negative 4/3. So that would be, let's see, negative 3/3 is about negative 1, so 4/3 is a little bit below that. Okay. Now, there's some other facts that I didn't ask about, but we could still find them. And I think it would be very useful to know if this thing actually crossed the horizontal asymptote at any point in time. So I'm going to take the HA and set it equal to the original function and just see what the algebra tells me. So multiply by the denominator, so 1 times x plus 3 is x plus 3 equals x minus 4. Now, when I try to get the variables together, they disappear and I get 3 equals negative 4, which is clearly false. So this graph does not cross the HA. Okay, now that was actually helpful. Because what I now can do, I know since it doesn't cross it, it's either got to hug it above or hug it below. The problem with it hugging below on that piece is I already figured out where it crossed the x-axis, and that wasn't it. So it's got to hug above on that side. This side I can already see the 2 points that it connects with, so I just need a smooth curve to connect those 2 points. And then we go on to number 21. Alright, number 21, we want to, let's try factoring it first. So that gives us, what is that, x plus, so 12 has a 7 in it. So it's got to be 3 and 4, so x plus 4, x plus 3, And then in the denominator, it's got to be 2 and 1. So x plus 2 and x plus 1. Okay. X-intercept, that's based on looking at the numerator. So if I set each of those factors equal to 0 and solve, I'd get negative 4, 0 and negative 3, 0. Y-intercept, imagine we go up and we plug zeros in to the original. I can see that I'm left with 12 over 2, so that means it's got to cross at 0, 6. Vertical asymptote would be the two numbers that are in the denominator there, sir. So that would be negative 2 and negative 1. Sorry, x equals negative 1. It's an equation. Horizontal asymptote, rid of my zeros. It's another same case. So looking at my leading coefficients, it's y equals 1. And let's see, I didn't ask it, but it'd be nice to know if it crossed the horizontal asymptote or not. So let's find out. So y equals x squared plus 7x plus 12 over x squared plus 3x plus 2. Okay, so when I multiply 1 by that denominator, 3x plus 2 equals x squared plus 7x plus 12. Okay, so the x squareds are going to cancel out. Let's bring the x's together. So to bring the 3x over gives me 4x on this side. And if I bring the 12 over, I get negative 10. So divide by 4, and I get negative 5/4. So this thing does cross the HA at negative 5/4, comma 1. Okay, so let's fill in what I know, and then we'll take a look at what's left of our picture. I know I got an HA at y equals 1. I got VAs at negative 2 and negative 1, so very tiny. Oops. So tiny I messed it up. Very tiny little section here. So there's negative 2. There's negative 1. Let's see. So plotting points. Negative 4, 0. So over here there's a point. Negative 3, 0. So right next to it there's another one. And 0, 6, there's something. And I also know that it crosses the HA at negative 5/4, comma 1. Well, negative 5/4, comma 1. Let's see, negative 4/4 is close to negative 1. So that's somewhere between less than negative 2. So I know it's got to cross it in that little tiny sliver that we have there. It's got to cross it at some place there. Okay, so let's do some hugging. Well, for whatever's going on, I can see it's got to come out there. So it's got to, I would assume it maybe bounces or something like that, but it's got to hug the asymptote. I know, especially after I got on so many in my face-to-face class about smooth continuous curves. That one is not the smoothest thing I've ever drawn in the world. We'll come back and talk about the middle. This other side, I can see it's got to come in and go there. Okay. Now the middle, is the middle ever going to cross the x-axis? And that's sort of a hint. And the answer being no, so that means there's a little tiny sliver. It's got to be above, so it's got to look like a very skinny parabola. Very, very skinny. But that's what our graph should look like.